So in part A of this question, we're told that a car has 6 forward gears, and we're told that the fastest speed of the car in first gear is 28 kilometers per hour, and in sixth gear, it's 115 kilometers per hour. Given that the fastest speed of the car in successive gears is modeled by an arithmetic sequence, we're asked to find the fastest speed of the car in the third gear. So what do we know about arithmetic sequences? So we know that we can work out the nth term by doing a plus n minus 1 multiplied by d. So we must think, what is an? So an is going to be the nth term. What is a? A is going to be the initial or the first term. So a is the first / initial term. So in our case, that's going to be 28 kilometers per hour, as we'll let n equals 1 for that case. And what's d going to be? So d is the common difference between terms. And at this stage, we don't know what d is. So for our situation, we're going to have a equals to 28. And then we also know that the sixth term, so a6, is going to be equal to 115. So we know this as this is what happens in sixth gear. So therefore, we can say that a6, which is equal to 115, is going to be equal to a, which is 28, plus n minus 1. So n is 6, so that's going to be 6 minus 1, which is 5. But I'll just leave it as 6 minus 1 just now, multiplied by d. So what we can do now is we can rearrange this equation and solve for d. So therefore, we'll have that 5d is going to be equal to 115. Then we subtract 28 from both sides. So therefore, we'll have that d is going to be equal to 115 minus 28, and then we'll divide that by 5. And then we put this into our calculator, and this comes out as 17.4. So what can we do now? So we have a general formula. We know what a is, and we now know what d is. So we can use this value of d here and a equals 28 to work out what the third term is going to be. So we'll write this down here. So we'll have that a3 is going to be equal to a, which is 28, plus 3 minus 1, and we multiply that by 17.4. And then putting this into our calculator, we therefore have that a3 is going to be equal to 62.8 kilometers per hour. So therefore, we can just write a statement that 62.8 kilometers per hour is the fastest speed of the car in third gear. So therefore, we've completed this question. It was worth 3 marks, and we get our first mark for working out what d was here. We then get our second mark for substituting these values in to then find a3, and then we get our third and final mark for concluding with the correct answer, which was 62.8 kilometers per hour. So we're now told, given the fastest speed of the car in successive gears is modeled by a geometric sequence, we're asked to find the fastest speed of the car in fifth gear. So we know this is going to have a similar technique to part A of this question, but we're going to be using geometric sequences. So we know that the formula for geometric sequences will be the nth term is going to be equal to a multiplied by r to the power of n minus 1. So in the same as the arithmetic sequence, we know that an is going to be the nth term. We know that a is going to be the first or initial term, but this time we have r instead of d. So we need to have a think, what is r? So r, rather than being the difference, it's going to be the common ratio between terms. So therefore, in our case, in the same as part A, we're going to have that a of 6 is going to be equal to 115 kilometers per hour, and a is going to equal to 28 kilometers per hour. So therefore, using our geometric sequence formula, we can say that a of 6, which is equal to 115, is going to be equal to 28 multiplied by r, and that's going to be power to 6 minus 1, which is 5. So therefore, we can say that r to the power of 5 is going to be equal to 115 divided by 28. So therefore, we then take the fifth root of this to find r on its own. So that's going to be 115 divided by 28, all to the power of 1 over 5. And we put this into our calculator, and this comes out as 1.3265, and so on. So therefore, we've worked out what r is, so we can now try and answer the question where we're asked to find the fastest speed of the car in 5th gear. So we can use the information which we've just found, so therefore we'll say we want the 5th term, and we know this is going to be equal to 28, because that remains the same, and we multiply this by our newly found value of r, which is going to be 1.3265. And what I did, I left the value and stored it in the answer part of my calculator. So I'll just write ... to show that we've used the full decimal places, which I've not even written down there. So that's a good way to make sure your answer is accurate. And then we're going to take that to the power of 5 minus 1, which is 4. So then we put this into our calculator, and this comes out as 86.6941, and so on. So therefore, we can round this to 3 significant figures, and that's going to leave us with 86.7 kilometers per hour. And therefore, we've completed this question, and we'll just write a little concluding statement. So 86.7 kilometers per hour is the fastest speed of the car in the 5th gear. So this question is worth 3 marks, and we received our first mark for working out the value of r. We then received our second mark for knowing to substitute in this value of r and be able to find the 5th term, and that was when we got it here, and we received the third and final mark for concluding with the correct answer, which was 86.7 kilometers per hour.